So good day everyone. This is my masterclass number 2. So in this masterclass number 2, our topics is finding area and volumes. So first, our learning objectives is to learn and apply the techniques in finding the area and volume, and to learn and apply how to plot and manipulate the given function in order to solve for the area and volume. So area. So in area, we're gonna have to find the area under the curve and the area between the curves. So first, we have the area under the curves. So for example, this is your y-axis and this is your x-axis and this is your origin. So for example, this is your curve, which is equals to y function of x. So we have here our curve. So let me um, this is your point A and this is your point B. So we're gonna find the area under the curve uh, from point A to point B. So this is the area we're gonna find, like that. So first, um, we're gonna make a point here. So this point, we'll call it x and y. So this is your x and y point. From here, we're gonna make a vertical strip. So this is your vertical strip. Shade it. Wait lang. So like that. This is your vertical strip from point x and y. So next, we're gonna find the length and the width of the vertical strip. So from here to here, from the top to the bottom, this is your height, which is your y. We labeled this as y, and your from the origin to the vertical strip, this is labeled as your x. This is your x, and then the thickness of your vertical strip is called your dx. This is called dx since the thickness is along the x-axis. So next, we will solve for the area. So first, we will take out your vertical strip and put it right here. So now this is your vertical strip, like that. So we label this as your y, the length. This is your y, and the thickness is the dx. Next, we will solve for our differential area. So this is our differential area inside the vertical strip. So this is your dA. So here, dA is equals to your y, which is your height, times the length or the thickness, which is your dx. So next, we will integrate both sides. So that we will have the integral of dA is equals to the integral of y dx. Next, we simplify. This will cancel out. So your area is equals to the integral of y times your dx. So from point A to B. Dili. So this is now your formula for finding the area under the curve. So this is your example number 1 in solving the area under the curve or the line. So first, we're gonna have to plot your line. So in finding the line, since it is not stated in the graph, you will use tabular method. So in tabular method, this will become x and y. So first, our value of x is 0. So next is to distribute 0 from your equation to your equation. So x here will become 0. So 3 times 0 is equals to 0 plus 3, and then your y will become 3. Next, when your value of x is 1, 3 times 1 plus 3 is equals to 6. So by using tabular method, we have now our points. So this is from 0 to 3. Use this as your 3. And then 1 to 6. This is your 1. Let's say this is your 1. And then you put here your 6. So this is your 2 points. Oh, wait. This is now your line. So your line here will be equals to y is equals 3x plus 3. Next, since it is from 0 to 5, we have our point from 0 to 5. We'll call this here 5. So we will solve for 0 to 5. Solve for this. So next, we will use now our vertical strip. So we'll plot our vertical strip. We put here, point here, and then this is called your x and y. So this will be your starting point in order to make your vertical strip. So we'll plot our vertical strip. Then this is now your vertical strip. Basta shaded na sa. Wait lang. So next, we will identify our x and y. So as we recall, from the concept, from the origin to your vertical strip, this is called your y. Your x gali. And then from the top of your the height of your from the height of your vertical strip is called your y. So this is your y. Next, the thickness is your dx. So next, since we plotted it, we'll solve for the differential area. So first, we take out your vertical strip. Let us put your vertical strip here. Imagine this is shaded. The length is your y and the thickness is your dx. So your differential area is equals to y times your dx. Next is to integrate both sides. So this will become a, and the is equals to the integral of y times dx. So this is now your formula. Wait. So the point here is from 0. The limit is from 0 to 5. So this is now your limit. So next, since we know our y and we know our dx. Y cut lang. So next, after this, we know your y. So your y is equals to 3x plus 3. So it will become the integral of from 0 to 5 is equals to 3x plus 3 times your dx. Next, we will integrate your y. I mean your function here. So the integral of 3x is 3x squared over 2. And then the integral of 3 here is 3x. And then from 0 to 5. The limits from 0 to 5. So next, we simplify this. Become 3 halves. Wait. So 3 halves x squared plus 3x. So next, from 0 to 5. Next, we will distribute your limits. So first, you have 5. So 3 halves times your upper limit, which is 5 squared, plus 3 times 5, um, minus your lower limit, which is 0. So 3 halves times 0 squared is equals to 0. And then 3 times 0 is equals to 0. So this is your 0. This is your lower limit. So I'll put here this. Then we simplify this. And then we have um, 3 halves 0 squared. I mean 3 halves times 5 squared. Wait. This will be equal to 75 halves uh, halves plus 3 times 5 is 15. So this is now your final unit answer, and then your unit of measure is squared unit. So this is your for example number 1. For example number 2, we have find the area under the curve y is equal to the square root of x from x is equal to 0 to x is equal to 4. So first, we're gonna have we're gonna find your points. So for solving the points, we will use again our tabular method. So this is your tabular method here. So if x equals 0, then the square root of 0 is 0. And then if your x equals to 1, the square root of 1 is equals to 1. And then we'll input here 4. And then the square root of 4 is 2. So this is now your points. 0, 0, 0, 1 to 1. Wait, let me label it 1 to 1, 1 to 1. And then your 4. This will become 4. Wait lang. Napupunta. This is your 4. And 2. This is your 2. So 2 to 4, 4 to 2. And this is now your graph. So assuming this is curve, like that, from the region. Next, according to here, we'll solve for under the area under the curve from 0 to 4. So this is your area. Next, we'll plot for our vertical strip. So put here, point here, and then this is your xy, and then this is the start of your vertical strip. So this is now your vertical strip. Like that. Next is to find the length and your height. So, and the width. So from here to here, this is your height, which is equals to y. And then from the origin to your vertical strip, this is your x, and this is your width. I mean the thickness. This is now your dx. So, wait, our curve here is equals to y is equals to square root of x. So now, we will solve for our differential area. So, put here first, always put first your vertical strip and then label it. This is your y, and this is your dx. So we'll solve for the differential area. So again, differential area is equals to y times dx. So integrate both sides. Become area is equals to the integral of y times dx. Since this is from 0 to 4, so your limit here is from 0 to 4. Next, we will distribute the value of y. So remember that the square root can be equal to the square root of a number is equals to the number raised to 1/2. So if this is cube root of a number is raised to 1/3, like that. So we'll put here the integral from 0 to 4, and your y become x raised to 1/2, and then times your dx. So next, um, we will integrate it. This, so x 1/2 plus 1 will become 3/2. So 3/2 over 3/2 right here. Then your limits from 0 to 4. Next is to simplify. Just become 2/3 x raised to 3/2, 0 to 4. Next, we will distribute the value of your x. So since it is 3/2, if we simplify this, this will become square root of x raised to 3. That's right, raised to 3. So this will become 2/3, and then square root of x times your square root of x raised to 3 from limits 0 to 4. And then next, we will solve for the limits. So this is 2/3. So the square root of 4 is 2, and then we'll raise it to 3, will become 8. And then we will minus it to the 0. 0 square root of 0 is 0. Raised to 3 is equals to 0. So now, your final answer, if we multiply this, we'll get 16 over 3. And then labeled as squared units. So this is now your final answer for this example. This is now our new subtopic, which is called the area, solving area between curves. So our concept here is when there are two curves or line. For example, we have a line here, and this line is called y equals function of x. Then we have also another line here, like that. Then since it has two lines, we call this your y1 and then your y2. So like that. Next, we'll solve. First, we'll plot our vertical strip. So set a point here. Call this your x and y. Then this is the starting point of your vertical strip. Now you plot your vertical strip. So now this is your vertical strip. Next, we will solve. We will determine our x. Before that, since it has two intersecting lines, we'll call this your A and B. Like that. Next, where are we? Sa may determining your length, width and height. So, from the origin to your vertical strip, this is your x. And then the thickness is your dx. Since it is a line between curves, it is finding the area between curves. We have here, we have two um, two heights. So from the y1, from the first line, from the line here, from your y1 down to your x-axis, this is called your first length. Since halin sa y1, we will call this as your y1. And then, from the top, since halin sa may y2, then the height here will be called your y2. So this is your y2. So the height between your y1 and your y2, since this is your y2 and this is your y1, we'll call this y2 minus y1. The height here will be y2 minus y1. So we will solve for um for the here, for the vertical strip here. So again, we'll take out our vertical strip, put it in here. So this is your y2 minus y1, and this is your dx. Then again, solving for the differential area, we have since this is your y, kung sa may between under the curves, this is your y, so distribute lang natin. So this is will become y2 minus y1. So y2 and y1 here are interchangeable. So depende pag gusto ka kung din mas mauna. Same man lang na gyapon. So next, integrating both sides, area here will equal to the integral of y1, y2 minus y1 times dx from, since this is A, our point, if we have 2 points, this will become A to B. Our limits will become A to B. So now, this is your formula for finding area between curves. So this is your first example in finding the area between curves. So here we have our graph. So this line is called your y is equals to x, and this line, this curve, which is a parabola, is equals to x squared. So first, we have the intersection. This is 1, 1, and this is your direction here. Intersection gali 0 to 0, 0, 0 gali. So first, we will find your we will plot your vertical strip. So here, for example, we have here our vertical strip where we have our point here. So this is equals to y, x and y. So like that. This is now your vertical strip. Done. Next, we will plot for our x and y's. So from the origin, from the origin to the point here, we call this x, your x. From the origin to your vertical strip is your x. And the width is your dx. Next, solving for the height. So, the first height here, um, since your first height is located in the parabola, so this is your height number 1. So this is your height 1. I mean y1. Wait. This is your y1. And then from the second line, or your y is equals to x, to the x-axis, we call that your y2. Like that. Next, since it is plotted, we'll solve for the we'll solve for the differential area first. So, by the way, in solving the intersection, we have here intersection. In solving for the intersection, we will use y is equals to y. And then your y here is your x squared. And then your y here is equals to x. So we will manipulate it. So we will put it in this side, the left side, so it will become negative. Then this will be equal to 0, and then factor out x. X will be it will be x minus 1 is equals to 0. So therefore, x is equals to 0. Alright? And then your x minus 1 is equals to 0. So your x will be eventually become 1. The next step here is solving for the differential area. So we take out your vertical strip, put it in here, and then label it as your kulang ulit. So ang area from here, ang height from here to here is your y1 minus y2. Like that. So this is your y1 minus y2, and this is your thickness, the dx. So now, let us proceed. So, the differential area, so formula is equals to y1 minus y2 times your dx. Next, integrate both sides. We have a is equals to the integral of y1 minus y2 times your dx. So next, we have So next, we will distribute. Ang limits gali. So this is your 1, 1, and this is your 0, 1. So this is your limits. So it is the limit is 0 to 1. So next, we will distribute the value of your y1 and y2. So this will be the integral of y1. Y1 is your na label. So since this is your y1, this is your y2 gali, like that. So your y1 is equals to x squared, and then your y2 will be x times your dx from 0 to 1. So next, we will integrate it. So x squared will become x cubed over 3, and then minus it by x. This will become the integral of x is x squared minus 2. And then your limits. Next, simplifying 1/3 x squared. And then distribute your 1 here. So 1 cube is equals to 1 times the 1/3 will become 1/3. And then next, your 1/2 here, distribute it by 1 times 1 will become 1/2. So, and then 0, when you distribute here 0, will be equals to 0. So now, you have your answer. We will minus this. So, in in subtracting function, we have first function here, fraction here, and then the second, we will cross multiply it. So, and then divide it um, by the product of the numerator. So, this will become 3. I mean 2 bale. Sama mga 3 minus 2. And then the product of the denominator, which is 6. So, this is your answer. Become 1/6. So, this is your final answer. Then label as 1/6. Then label as squared units. Like that. So, this is your answer from example number 1. So, in this example number 2, we will use two methods, the vertical and the horizontal strip. So first, we're gonna use the horizontal strip. So in order to plot this, we will use our tabular method. So first, we need to plot the graph. So this is your graph, like that. This is your y-axis, and this is your x-axis, and this is your origin. So since y here is equals to square root of x, we will use our tabular method to find the first curve. So this is y is equals to square root of x. So by using tabular method, we will find our first curve. So if your x is equals to 0, then your y is equals to 0 because the square root of x, square root of 0 is 0. So next, if your x is equals to 1, then the square root of 1 is equals to 1. Then we will use 4 here to make our square root of 4 2. This is our first graph. So let's say this is your 1 and this is your 1. So we have here our first point. Then 4 2. So let's say this is your 4 and this is your 2. So now you have here your second point. So from 0 to 0, we have here our graph. We're going like this, a slightly curved graph with like that. So this is your y is equals to square root of x. Next, we will solve for the y is equals to the cube root of x. So we will use again our tabular method. So if your x is equals to 0, then this is 0 automatic. If your x equals to 1, this is also 1. But we will use 8 so that our cube root of 8 is equals to 2. That's right, 2. So wait, let me expand this. Like that. So this is your x-axis. So let's say we have here our 8 and then our 2. So we have here our line, our second curve. So same as here, 1 1, then 2 2. So it will go like this. Para do medyo curve gawa. Like that. We will erase Um, oh no, wait, again, this is your 1, and this is your 1, so we have our point here. And then this is your first line, and then this is your second line, like that. So this is 1, 1, our point here is 1, 1. For example, ano lang, ang, imagine this is your point 1 and 1. So now, we have your second curve, which is your y is equals to the cube root of x. So next, we're gonna solve. First, we will use um, we will use our vertical strip. So let's have a point here. This is your x and y point. So we will gonna make our vertical strip here. So this is now your vertical strip. So here in our vertical strip, the distance from the origin to your vertical strip is called your x, right? And then the thickness or the thickness of your vertical strip is called your dx, since it is in the x axis. So the distance between your x-axis to the bottom part of your vertical strip is your let's call this, since it is connected to the first first curve, like let's call this y1. So this is your y1. Next, the distance from the upper part of your vertical strip down to your x-axis is called your y2, since it is connected to your second line. So next, the area between your the height of your vertical strip is called your y1 minus y2. So now we have all the parts needed to be solved in order to solve the problem. So next, we'll take out the vertical strip. This is now your vertical strip. Then we'll label it. The length of your vertical strip is called your y1 minus y2. And then the thickness is called your dx. So we'll find our differential area. Right. This is your differential area. Now the formula for the differential area is your y. Since there are two y, we will call this y1 minus y2 times your dx. Next, we will integrate both sides. So we have, so we have a is equals to y1, the integral of y1 minus y2 times your dx. So since it has the intersection from 0 to 1 here, so our limit is from 0 to 1. So next, we will distribute the value of y. So let's put our integral and the limits. So your y1 is the square root of x, and then minus your y2 is the cube root of x. Like that. Times your dx. So we will simplify this. Let us put here the top. Get na lang the butang for space. So we will simplify this, and we will make this into 1/2, raised to 1/2, and then this will be raised to 1/3, and then we will integrate it. So by mentally integrating, the integral of x raised to 1/2, just add 1 to the exponent, it will become 3/2. So 3 halves, the integral of x raised to 1 half is 3 halves over 3 halves. So 3 halves, if we reciprocate it, if we put our denominator into the numerator, we will have our 3/4. So 3/4 x raised to 4, I mean, sala gali. 3 halves, 2/3. 2/3 I mean, 2/3 x raised to 3 halves. So this is now your y1. Then minus it, subtract it to your y2, which is 1/3 squared raised to 1/3, and then you add 1, it will become 3/4. So 3/4 over 3/4, if you simplify it, I mean 4/3 gali, 4/3 times 4/3 at what I mean, this is 1/3, and then when you add it by 1, it will become 4/3. So 4/3 x raised to 4/3 over 4/3 will be equal to 3/4. 3/4 x raised to 4/3 with the limit from 0 to 1. So now we will distribute the value of x to the limit to our x. So 1 here, we'll multiply it by 1. It will become the same, and then minus it to 1, and then minus it to the 3/4 multiply it by 1, and then raise to 4/3, and then we will subtract it from the from the we will subtract the answer here to the second limit when being substituted to 0, from 0 gali. So so our answer is sige, let's simplify ka na lang. So this is now 2/3. So your answer now is 2/3 times 1 raised to 3 halves, and then minus it by 3/4 times to 1 raised to 4/3. And then this is your first substitution, and then next is 0. Then if you simplify this, your final answer will end up 112. And then the unit of measure is square units. So now this is your answer in the vertical strip. So now we have here your concept of polar curves. So I'm going to plot here. So this is your x-axis and then your y-axis. So let's say we have here our polar curve. Wait. Let's say we have here your polar curve like that, or so yeah, this is now your polar curve. So we label this as your polar curve. Again, your polar curve. So next, your polar curve is equals to your r. Is equals to the function of your theta. So r is equals to the function of your theta. So this is now your polar curve. So assuming this is the area you want to solve. So this from this point to this point, and then from this point to this point. So from this point to this point, this is your theta 1, and from the second point to this point, to your x-axis, this is your theta number 2. Okay, so and then this is your radius, and this is also your radius. So it has different radius because it has different angles. So next, we will create a sector. So, uh, assuming this is your circle, then a sector is a part of your circle. So, wait. So, ano? So, this is, uh, this right here is your sector. Sector is a part of your circle. So, yeah, we will create here your sector or your sector strip like that. This is now your sector strip right there. So this is your sector strip. So this is now your R, your radius, and this is now your radius, and then the thickness of your circle is your d theta. So this is the thickness of your circle. So next, like in the area, we will um, remove our sector and put it right here. So like that, like that. Wait, like that. That. This is your now your sixth sector. Then after that, we'll label it. This is your R. This is your R, and then the thickness is your d theta. So the formula for sector differential area will solve for the differential area. This will become 1/2 r squared times your d theta. Next, if we differentiate both sides, we have the differential of r squared, 1/2 r squared kali, times your d theta from point theta 1 to theta 2. So now, this is your formula for the polar curves. So where do we get the 1/2 pi r squared? Simply because sector here, this is your pi. Wait, what? Babe, amo ni sector mo. You have here your angle, which is your theta, and then you have your r and r. So sector, a sector, area of sector is equals to 1/2 r squared. Theta gali. Ito, theta in radian form. Like that. Sorry for the messy hand. Like, it's messy handwriting. So next, so for example number 2, we will define the quarter of a circle. So this is your graph. This is your x-axis and this is your y-axis. So this is your circle, and we will find a quarter of a circle. So this is your quarter of a circle. So here, the quarter of a circle is equals to x squared plus y squared is equals to 25. Right? So as we call x is equals to r cosine theta, and then your y is equals to r sine of theta. Right? So here we can distribute r sine and r cosine. So x will be r cosine theta. So since this is squared, so square this, and then add it to your r sine theta. And then squared. Then equals to 25. So here, if we distribute the root, the exponent will become r squared cos squared theta plus r squared sine squared theta. Then this will be 25. And then simplify. Wait. Since it has the same r and has the same exponent, we're gonna factor out here first. Then multiply it to the cosine squared theta, and then add it to sine squared theta, uh, and then we will get the root of the 25, which is 5. So here, we will simplify this. So cos sine plus arc sine, cosine plus sine will be 1. So this will cancel out. This will become the 1. Then we have left is your r squared is equals to 25. Oh, shumay. Wala pa gali na squared. So 25 pa di. So amo na ni pag convert mo sa root. So r here is equals to the square root of 25. And then kay ang kunig is square root mo duwa both sides, makancel out ang 2 kag square root. Ang dire kay ang value kang square root is 1/2. So 1/2 times 2 mo makancel out. So amo na ni. So r is equals to square root of 25, which is your 5. So this is your circle. Next, circle pa ni gali. So we will solve for the area. So we take out the we'll take out a sector here, the quarter of a circle. Dapat ka mo dyan. Right there. No. We will plot again. So this is your circle. This is your quarter of a circle. And then we're gonna use our we're gonna use our sector gali. We'll use our sector. So this is our sector strip, I think. So take out your sector. Amo na pag take out mo ka sector. So your sector is here. For example lang, this is your sector, and then this is your r, and this is your r, and this is your d theta. Next, this is your differential area. So the differential area of your sector is 1/2 times your r squared d theta. Right. So next, distribute the value of we will apply the integral gali. So area is equal to the integral of 1/2 r squared d theta. Right. So the limit here is 0 to pi over 2. Next, distribute the value of the r here. So will become we will factor out 1/2 here. So r is equals to 5, which is 25. R squared is 25 because 5 times 5 is 25, and then multiply it to the theta. So this will leave us to 25 halves, right? And then your theta. Oh, wait. Sakto. 25 halves d theta. Then we'll have here, makancel out ni, kay simplify mo, makancel out, theta na lang, bilhin. So, then our limits is from pi over 2. So next, simplify this. So the final answer will be 25 over 4 pi square units. So now this is your final answer for this example. So for our next topic, we have volumes. Finding the area of volumes. So in finding the area of volumes, we have three methods. We have the disk method, the shell method, and the washer method. These are the methods in solving for volume. So first, let us discuss our the disk method. So for the disk method, we have here example number 1. Um, uh, our concept select. First, we have concept for the disk method. For have here. So let me plot first. This is your y, this is your x, and this is your origin. So, for instance, this is your curve. So, we're gonna find the wait. So this is your point A. Yung point pagalit. So this is your point A, and this is your point B. So we're gonna find the area between point A and point B. So again, we will use uh, for this method, we're gonna use our vertical strip. So the point here is called the x and y. So um, this is your vertical strip, like that. Now this is your vertical strip. So let us label it. So the distance between the origin to your vertical strip is called your x, right? And then the thickness of your vertical strip is called your uh, dx. And then the height of your vertical strip is called your y, right? And that's right. So in the disk method, uh, we have here um, your axis of rotation. So it is rotated in the x-axis. This is your AOR. So when it is rotated in the x-axis, we have right here. So this is rotated in the x-axis. So yeah, so this is the thickness. For example lang, ko second mouse. This is the thickness of your disk. So as the previous topic, we need to get the what you call the disk. So we put here the disk. Wait. Then like that. So this is now your disk, and this is your AOR, your axis of rotation, right? So let us label it as this is your y, and the thickness is your dx. So in solving, wait, it's rotated the x-axis. So for solving the volume, we have formula of the differential of volume is equals to the pi y squared times your dx. So integrating that, we have the volume is equals to the integral from point A to point B, then your pi, and then your y squared, and then times your dx. So now this is the formula for your disk method. So for your example number 1, and solving for the disk, we have here that determine the volume if the area under the line y is equals to x from x is equals to 0 to x equals to 5 is rotated about the x-axis. For your solution, this is your solution. So we're gonna graph it. So assuming this is your graph, like that, this is your origin, this is your y-axis, and this is your x-axis. Since it is stated that it's rotated but the x-axis, so this is your AOR. Like that. Next, um, from 0 to 5. So this is 5. Like that. So y is equals to x. So the graph y is equals to x is simply a line rising vertically. I mean horizontally upward to the right side. So this is your y is equals to x. So we're gonna find the area uh, from x equals to 0 to x equals to 5. So we're gonna find the area right here. So inside from 0 to 5, right? So first, I'm gonna label. Wait, get to the laptop. So this is your point where your vertical strips will be done. So this is now your vertical strip, and your point here is called y and x. So the vertical strip here. Let me shoot it. So next, determining the value of x and y. So the length is your y, and from the y-axis or the origin to your vertical strip is called your x, right? So then your thickness of the vertical strip is called your dx. So this is your dx. So since it is rotated uh, about the x-axis, this will rotate downwards. Like that. Now this is your disk. Like that. So solving, we will take out your disk, put it in here. So this is your disk, like that, and this is your AOR, right? So labeled it. So from here to here, this is your y, and then the thickness is your dx, right? Next, solving. So so next, dv, differential volume, is equals to pi y squared dx. Integrating both sides, we have volume is equals to the integral of y pi y squared times your dx. Since from it is from 0 x to 0 x equals to 0 to x equals to 5, so our limit is from 0 to 5. Then since the pi here is constant, we put it outside, and then we will put here the limits, integral and the limits. So since we will distribute the value of y here first. So the value of y here is equals to x. So this will become x squared, then times it to dx. So integrating x squared is equals to x cubed over 3 times your dx with the limit from 0 to 5. So distributing the limits, we have first we have to how to simplify this first. So pi is over 3, right? Because we have here over 3, so it is the same. So multiply it by x cubed dx from 0 to 5. So next, we will distribute the value of x. So this will become pi over 3. So 5 here is the limit, so we put 5 here, and then cube, and then minus it to 0, right? Like that. So 5 cube here, uh, 5 times 5 times 5, 5 times 5 is 25, and 25 times 5 is 125. So we have here 125 times your pi, and then over it by 3. And then your unit of measure here is your cubic meters. Cubic unit ulit. So, this is now your answer to your example number 1. So, next, we have the shell method. So, in shell method, let me first give you the concept of the shell method. Wait, tap it down. This is your y, this is your x, and this is your origin. So here, shell method, in the shell method, our axis of rotation is in the y-axis. So this is your AOR, your axis of your rotation. Next, we have here a curve or a line, depending. So the line here is f of x is y is equals to f of x. Kaya doon ko lang. Y is equals to the function of x right here. So, for example, we have here the point A and then your B. So, we will solve for the area between your point A and your point B. So now, we will use vertical strip. So again, we will have a point here. So this is your x and y point. So from here, you can create a vertical strip. So now this is your vertical strip. So in your vertical strip, we have here the height of your vertical strip is your y, right? And the distance between the origin to your vertical strip is called your x. And then the thickness is called your dx, right? Next, since it is rotated in the y-axis, we will have to rotate here. So, like that. Like that. So, wait, to the thickness. So now, this is your shell method. This is also called a cylindrical tin can, right? Next, we will remove the shell. Yes, we will remove the shell and put it here. So like that. I mean your cylindrical can, like this. And then we will label it. Wait, so this is first your axis of rotation, your AOR. And then the height is called your y. And then the thickness, imagine this is the thickness. This is your dx. And then the distance here to here is your x, right? So now, this is your representation of a cylindrical tin can. So here, in shell method, since this is a cylindrical tin can, we'll imagine that we will slice it at this point. So after slicing, we will have a very long vertical figure. So here, we have here the length of your vertical rectangle. Horizontal gali. Horizontal rectangle will be 2 pi times x. And then the height still remains the same. This is your y, and then the thickness. If you can imagine, the thickness here, right, is your dx. And then the space here is your differential volume. So we will need to find your differential volume. So next, we'll solve for the differential volume. So this will become the length times your height times your thickness, which is your dx. So 2 pi y, right? 2 pi times y, 2 pi x gali, 2 pi x times your y times your dx. So differentiate both sides. We have the differential of 2 pi xy times your dx, and our limit is from a to b, right? A to b. Now, this is your formula for your shell method. For your example number 1, using the shell method, we have the area under the curve y is equals to sine x from x equals to 0 to, this is 2, wait, 2x equals to pi over 2 is rotated about the y-axis. So determine the volume generated. So yes. So for your solution, let us first graph. So you have here your y-axis, right? Or y-axis, and then your x-axis. So this is your y, this is your x, 0. Since it is rotated about the y-axis, we have here your axis of rotation, or your AOR, right? So since it is from from 0 to pi over 2, so assuming our graph here will be equal to like that. Yes, like that. Since it is y is equals to sine x. So if we do this graph of y is equals to sine x. So like that, it is in decrease here, right? So we have here. So this is our origin, and then the half here is pi over 2, and then here is your pi, and then 3 pi over 2, and then your pi, 2 pi. So here is your, again, pi over 2, right? And then here, sakta. Then here is your pi. Okay. So, again, like that. Yes, it here is your pi, right? So, correct. You have here your pi. So, then your 3 pi over 2. 3 pi over 2. And then your 2 pi, right? So, as you can see, 0 to pi over 2. So, we'll solve for the area here. So, by using our vertical strip, we will solve for this. So, here will be equal to your xy, so point here, xy, right? Since this is your vertical strip. So, from the origin to your vertical strip, this will become your x. The thickness is your dx. And then the height, let's put here, the height equals to your y. So since it is rotated from the around the about the x-axis, it will rotate like this, right? And then like that. So this is also a cylindrical tin can. So next, we will take out your cylindrical tin can. We will put it right here, like that. So this is your AOR. This is your height, lapaw. This is your height. This is your X, right there. That is your X. And then the thickness here is your DX, right? So next, we will cut it in half to make horizontal rectangular form. So here will be your 2 pi x. This is your y, and then the thickness here is your dx. Then the area here is your differential value, right? So for solving for the differential value, again, the formula is 2 pi x. Wait, 2 pi x times your y times your dx. So, wait. So, differentiate both sides. So we have from 0 right here, 0 to pi over 2, right? Then you multiply it by 2 pi x, 2 pi x times your y times your dx, right? Next, um, since 2 pi here is constant, we'll move out, factor out it, the integral. So this is 0 to pi over 2. Then the remain is y, is x and y times your dx. Okay, so here, um, so we will integrate the, we will distribute first your x and y. Sure. So since it is 2 pi, then distribute the value of y 0 here. So this is your sine x, x sine x, right? Then your dx. Then move this to here. So here now, the integral of x, and then solving it, and by solving it, we have your final answer. So we have 2 pi as your final answer, and then it is labeled as square units, right? So first, calculate it. Pi, erase it. 2, and then your pi, which is alt 227 or 224. Ano ba yung pi? Command for pi is alt 224, which is 8. Alt 227 is your pi, yes. So this is alt 2 to pi, 2 to 4, 2 to 7 is equals to your r. So multiply it to the integral from, this is your 0, 0, and then your pi over 2. Hindi natin but ano naman? Ari. From your pi, this is pi, again, all 2 to 7 over 2, and then times it to your x, and then multiply it to sin x, right? And your dx. So calculate final answer. Right, have your 2 pi. 2 pi. Yes, correct. You have your 2 pi as your final answer, and label it as your as squared units. So this is now your final answer. So next topic, we have the next method is the washer method. So Here, in the washer method, the concept here is, wait, let me graph it first. So we have a graph here. This is your y-axis, this is your x, and this is your origin. This is your x, and this is your origin, right? So in here, um, we have a point here. This is your point A, and then your point B. Since we have a curve here, assuming this is a parabola, walang ko drawing parabola. Basta top of a curve here is your parabola. Ganda lang. So this is your point B. This, wait, let me delete it. Dot, like dot, pencil, right there. So this is your point A and point B. Next, we will get your vertical strip. So the vertical strip here, my point here, this is your x, and this is your y. So vertical strip here, and then here. Right? Right there. So this is now your vertical strip. So assuming you have here a line. So this line, which is your axis of rotation, labeled as axis of rotation. Linear is equals to y equals to b. Right? So next, we'll solve. We will label it first. So from your origin to your vertical strip, this is your x. The thickness, same as your here is dx. Slash other examples. This is dx. The height here. So the height here is your y, right? Right. Next, we have here from your axis of rotation to your x-axis. Right? This is called your b, since it is attached to your axis of rotation, which is your y equals to b. So next, we'll find the value of the height from your point A to B, and then from your curve to the axis of rotation. So since this is B and this is Y, this will be called B minus Y. Okay? So next, we will apply um, the washer method. So from here, this will become right here. Wait, taas ng tagamay. Wait. From here, from here, like that, become right there. So this is your first step. And then you have here from the bottom to the top. Ito, yes, sa babaw. Now, this is called your washer method. So as you can see, this is like a double disc, but this is like a disc, but there's a hole inside the disc. So this is your washer, right? Like that. So if we okay, so if we take out the washer, this will become right here. Wait, here, and then another hole. It's like an avocado, but when you draw, It will be like that. Yes, like that. Okay. So this is your AOR, right? So the distance from your inner disk to your uh, axis of rotation here, diba? From your inner disk to the point here to your axis of rotation is called your v minus y, right? And then um, from your axis of rotation down below, from here to here, is called your v, right? So now we'll solve for the dv, the differential volume. So now put here, wait, sa baba, tabata. Put here the formula. So dv is equals to pi v squared times dx, right? So this will become um, okay. So b here will become b minus y. So pi here, and then put b minus y times your d of x. And then integrating both sides, you have volume is equals to the square root of pi v minus y, then raise it to 2. May 2 pagigali kay b squared, right? This is your b. This is your point b gali. Okay, like that. So since this is attached, undistributed value b, so this is your b minus y. Okay. Okay. So sala ni. So erase. That's it. So next, differentiating both sides, cancel out, then become pi times b squared minus b minus y squared times your dx, right? So now this is your wait, from point A to point B, this is your limit. Okay, baliktad. Point A to point B. Okay, you have now your formula for the washer method. So for the example number 1, assuming wait, we will graph first. Assuming you have here your x and y axis. So this is your origin. So assuming here we have a graph, we have a parabola that faces upward, and then right here the parabola na. And then a parabola with facing to the right, like that. Call this a parabola is equals to y is equals to x squared, and this parabola we call this y is equals to square of x, right? So midpoint, the intersection, assuming we call this 1 and 1. Like that. So this is also a parabola. Tapa mo ka na. So next, we'll solve for the washer. So first, we need to apply the disc, the vertical strip. So this is your point. The point here is x and y. Always x and y, unless it is given. Next, shade it. So next, from the y-axis, the origin gali, since this is the origin, to your vertical strip, this is called your x. Then the height, since it has two curves, we have two heights. So first, we have from this curve down to your x-axis, call this your y1. This is that. Then from the second curve to your x-axis, call this your y2, right? So since this is connected, the first curve, we will call this your y1, and this we will call this your y2. Okay. So next, uh, the thickness. Okay, the thickness of the vertical strip is called your dx. Okay. So next, we will apply the washer. So here, since it is rotating the x-axis, forgot, this is your AOR. So now, this will become the first and then the second disc. Okay. Okay. It's now your disc. So we will minimize the disc. We will move the disc and put it here in here. Okay. Let's right here, and then the disc will be right around right here. Like this is your disc, then this is your AOR. Okay, so we label it. Next, we will label it. So, but first the length of the vertical strip. So this is your y2 minus your y1. Okay, kaya pala. So from the inner part, this is your y1, right? y1, and then from the outer to here, the x-axis is your y2, and then the thickness is your dx. Okay? Okay. So next, solve for the differential value of the dishwasher. So, dishwasher for the washer galing. So next, using the formula pi y squared dx. So since it has 2, so this is your y2 squared minus your pi y1 squared times your dx. So integrating both sides, you have the integral of v is equals to the integral of pi. By the way, this is 0 to 1 because our intersection here and our intersection here is 0, 0 and 1, 1. So this 0 to 1. So next, since the common, we have pi, we take that out, and then we'll put the y2 squared minus your y1 squared, then multiply it to dx. Next, we have, we will distribute the value of x, the value of y here. So y2 is equals to the square root of x, right? So the square root of x raised to 2 will become x only. Okay. Since this is squared, sakto. So x squared raised to 2 will become x raised to 4th power, 4 to the 4th power. So, wait, may pi pagpili. So, times it by dx, 2 dx. So, this will become, since pi here is constant, then integrate it. Integral of x is x squared over 2 or 1 half. 1 half x squared. Minus integral of x raised to 4 is x raised to 5 over 5 or 1/5 x raised to 5. Diba? With the limits from 0 to 1. Okay. Ang isa. Okay. Put pi here first and then simplify. This will become 1 half. Distribute mo nimo ang upper limit So this will become 1/5. Okay. So simplifying further, we have 3 over 10 pi, and then your unit to measure, which is your cubic units. So now this is your final answer. So this is all for your for the master class number 2. So thank you and um, goodbye.